Good morning, engineers, and welcome back. Thank you for joining this week again. And if you watched last episode, then you already know what we want to do today. We want to build our first workflow. Okay, let me tell a little bit more about this workflow. Usually, you always have this scenario that in organization you have huge CAD teams while you have small CAE teams. So usually there is a ratio between 1 and 10, or even I've seen 1 to 100. And this leads to the following situation. The CAD team can't run simulations on all the changes they wanted to have simulated, or if they get the resources for a simulation run, then sometimes it takes a day, 1 week, or even 2 or 3 weeks, which can lead to the situation that the CAD design already evolved over the time and the simulation result doesn't matter to the current CAD status anymore. On the other hand, in the CAE team, they are frustrated, they are overloaded, they're buried in work. And so now imagine there's a super smart engineer, and this person thinks about, could I store all my simulation knowledge into one workflow and share it with the CAD team? And that's what we will do today, building exactly this workflow on the first step. Okay, let me quickly share my screen. Just take a second. Here we go. So already told you in the last episode, on the right hand, we have the viewer where we can visualize geometry, but also the pre and post processing of simulation. On the left hand, we have the canvas. And in the canvas, we can drag and drop pre-coded nodes. And that's what we will do here. So just inserting it, we see on the left hand, on the left side, all the inputs, on the right side, the outputs. And we always just need to connect one output to the input of the next node. So in our case, we'll choose the file path node. And in this node, we just can upload a geometry. And here we will upload a CATIA file. So we can see the CATIA file in the viewer, and you can already see the geometry has some attributes, so blue colored surfaces and green colored surfaces. So just think about simulation. In simulation, you need to define your boundary conditions. Boundary conditions mean you need to define, are there areas where you want to apply forces? Are there areas where you want to apply, for example, some fixed conditions? And that's exactly what we will do right now. We say on the green colored surfaces, we want to apply a fixed displacement. And on the blue colored surfaces, we will apply a force. Okay, for that, first we need to filter out the surfaces. And we just search for filter. We'll find this filter attribute nodes, just need to connect it to the right input. We can already see, okay, it's searching for color, and we just need to define this color. We'll start with blue, just saying, okay, please construct me this color. And if we hide now the geometry, we can see all the blue colored surfaces. We'll copy and paste everything and do the same thing just for green. So means we need to switch from blue to green, and also can also see the green colored surfaces. And that's already the first pretty smart thing of our algorithm, because it doesn't care if you have one green colored surface or 100. It always will find the surfaces. In the next step, we will build the simulation part of this workflow. So therefore, in the platform, you find a lot of templates. And we will just open the templates, say FEA, saying full workflow, choosing here the simple FEA workflow, and say import this. So the workflow is already running through because there are some stored data behind to explain a little bit the workflow. And what we have to do is just replacing all this pre-stored data. And here the first thing, we will choose element size. In our case, we say 10 to make it a little bit bigger so that it performs quicker now in this video. For the body, we just connect our imported geometry. In the next step, we see the material here. Now it's hard-coded. We will change it over time. So in one of the next episodes, we will focus on this block. And then there are already here our boundary conditions, so the force and the fixed displacement. The RBE elements we don't need for the moment, but in one of the later episodes, we will also focus on this again. And now we just connect the blue-colored surfaces. I think we said we want to apply the force. And on the green-colored surfaces, we said we want to apply this fixed displacement. Okay, our boundary conditions getting assembled in a linear static mechanical model. We construct the whole model, put it in a FEA solver, run the simulation, and now we can just quickly hide this so that we can hide all the things we don't need anymore. And now we can visualize, for example, the element stresses or the nodal displacement, for example. So now we have built our first workflow. There's one last thing we will do this week. We will exchange the input. So let me quickly open it. So in the first step, we imported a CATIA file. Now we will import a step file, for example. Quickly hide it here just to see what we imported. Also geometry with the same attributes, blue-colored and green-colored surfaces. This time different number of surfaces, but the workflow runs smoothly through. And at the end, we see our result, our simulation result. Okay, say that. We are done for the day. Thanks for joining. And a quick teaser for next week. Next week, we will focus on exchanging this import node to specific CAD import where we can remote control the CAD model. Okay, thank you and see you next week. Bye-bye.